Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Before that, let me introduce my group member from Group 8, Material for Aerospace Application. Number one, Muhammad Amirul Izani bin Muhammad Ridwan, and then Aina Nadira binti Abdul Razak, and then Idlan Aidit bin Muhammad Aijuddin, and then Muhammad Hajim bin Muhammad Saleh, and then I am Salman Parlingan Syota. So, introduction. Aerospace engineering is a broad field that involves the design, development, and testing of aircraft, spacecraft, and related systems. The function of material in aerospace engineering is to provide strength, durability, and reliability to the component and system used in aircraft and spacecraft. Material used in aerospace engineering must meet strict requirements for weight, strength, stiffness, toughness, corrosion resistant, and resistant to high temperature and other environmental factors. Material used in aerospace engineering can be categorized into metal, composite, ceramic, and polymer. Each type of material has its own specific character and properties that make it suitable for particular aerospace application.
My name is Aina Nadira binti Raza and I will explain to you the type of material that have been chosen. A variety of materials are used in the aircraft application based on their specific properties and compatibility with different components and structure. The material that have been chosen for our assignment, the first one is aluminum alloys 2034. Due to its low density, high strength to weight ratio, and high corrosion resistance, aluminum alloys are commonly used in the aircraft industry. Second, carbon fiber reinforced polymers (CFRP). CFRP materials are lightweight and have a great strength and stiffness. They are applied to reduce weight while retaining structure integrity in the aerospace applications. The third one is composite honeycomb structure. Honeycomb structure with a high strength to weight ratio, such as those built of aluminiums or fiberglasses, are utilized to provide structural support as well as insulation and acoustic qualities. The last one is high temperature alloys. Nickel-based superalloys are applied in high temperature application such as aviation engines, where they can tolerate tremendous temperature and mechanical stresses. These alloys have exceptional oxidation and creep resistance.
Hi, my name is Idlan Aidit and I'm going to continue the presentation about physical properties. There are four materials that we have chosen, which are aluminum alloy 2024, carbon fiber reinforced polymer as known as CFRP, composite honeycomb structure, and high temperature alloy. So, the first one is the physical properties of aluminum alloy, which is the color of aluminum alloy 2024 is typically a silver grey or light metallic grey color. It has a natural metallic appearance that is characteristic of aluminum and its alloy. The specific shade of grey may vary depending on factors such as surface finish, lighting condition, and any coatings or treatment applied to the alloy. It has high melting point and low density, which is 510 degrees Celsius and 2.78 gram per cm cube respectively. Next, the physical properties for CFRP. The color of CFRP is black. It has low weight due to the carbon fiber being extremely light and the polymer matrix being relatively light as well. The density of CFRP is low, so it can enable weight reduction in various applications without compromising its structural strength. The third material is composite honeycomb structure. It is lightweight material. The honeycomb design consists of a series of hexagonal cells which create a high strength to weight ratio. It also has a good thermal insulation properties. Lastly is high temperature alloy. The color for high temperature alloy is typically metallic nature, but as the temperature increase, this alloy can undergo oxidation, leading to the formation of oxide layers on their surface. This can affect the color of the alloy. It also have high melting point with the range from 1200 degrees Celsius to over 1600 degrees Celsius. It exhibit good electrical conductivity due to their metallic nature.
Mechanical properties. First, aluminum alloy 2024. It have a tensile strength of 310 until 455 megapascal. Yield strength of 230 until 410 megapascal. And it have a elongation of 10 to 20% and have a Young modulus or modulus of elasticity of 73 gigapascal. So, aluminum alloy 2024 have a hardness of 70 HB Berliner and have a fatigue strength of 85 until 160 megapascal. For carbon fiber reinforced polymers (CFRP), it have a tensile strength of 3000 to 7000 megapascal. Its yield strength is 2500 megapascal and have a elongation of 1 until 3% and have a Young modulus of 200 until 500 gigapascal. CFRP have a hardness of 62 until 67 HB Rockwell and have fatigue strength of 200 until 800 megapascal. For high temperature alloys, which is for our assignment, we choose a nickel paste super alloy, which have a tensile strength of 650 until 880 megapascal, yield strength of 350 and 550 megapascal, elongation of 46%, and have a Young modulus of 190 until 220 gigapascal, have a hardness of 38 HB Rockwell, and have fatigue strength of 200 until 800 megapascal. Microstructure of the aluminum alloys 2024 CFRP and high temperature alloys, which is nickel based super alloys. For aluminum alloys 2024, we can see there they have a larger grain size and grain boundaries. So aluminum alloys, which is aluminum, that obviously we know as have a higher ductility. For carbon fiber reinforced polymer CFRP, we can see there the tiny circle of particles there, which is reinforced. For this CFRP, the reinforced is carbon fiber, and the darker side, which is matrix. So for nickel superalloys, uh, it is consists of matrix phase of gamma, which is a fine precipitated and uniform dispersion of gamma prime, which is one or more carbide phase at the diagram.
Okay, now I will present about the fabrication methods and the applications of those material for aerospace applications. First, we have aluminum alloy 2024. As you can see in this slide, there are two types which mean each applications and fabrications. For application of the aluminum can be applied into the aircraft plane frames, aircraft wings, and its fuselage. As you can see, and in the left, there are example for the aircraft frames. And for these applications, the suitable fabrication method is consists of sheet metal forming, extrusion, and casting. Next, carbon fiber reinforced polymers, or as known as CFRP. The applications of these materials is wings for the aircraft and also the tails. Besides, it also can be applied to the cabin interiors such as seats, and also can be used for the engine fabrics. And the fabrication methods consist of the molding techniques, filament windings, and automated fiber placement, which are very recommended for using automated fiber placement. Okay, next we go to the composite honeycomb structures. For these materials, this materials is a very unique materials because of its structure itself, and the application is consists of the spoilers, rudders, and flap of a aircraft. And the fabrication methods must be conduct according to its procedures, or we can say according to its order, which is we can start from cutting, then we go to shaping, then curing, then lastly we finish with finishing methods. And for the last materials, which is high temperature alloys, this type of materials are very widely used for heavy duty types of applications, such as gas turbine component, such for example the blades and the nozzles, and exhaust system of an aircraft. Also, the example nozzle and diffuser. For fabrication methods, um, consists of melting, casting, heat treatment, and machining. I think that's all. Thank you.
Okay, conclusion. The aerospace industry commonly use aluminum alloy 2024, carbon fiber reinforced polymer, composite honeycomb structure, and high temperature alloy due to their unique properties. Each material has its advantage and recommended fabrication method, which are essential to achieving the best condition of the material application. Fabrication methods such as extrusion, sheet metal forming, casting, cutting, shaping, curing, and finishing are crucial in achieving desirable strength and quality. Adherence to safety standard is also vital to ensuring the reliability and durability of aerospace component and system. Overall, the careful selection and application of material, physical properties, mechanical properties, and microstructure and fabrication method are critical in aerospace engineering to ensure the success and safety of aerospace operation. Thank you.